Okay, let's go ahead and go over Systems 2.1. In this homework assignment, we're practicing a little bit with plugging in information and solving using graphing. So let's go ahead and see what we need to do. The instructions for numbers 1 and 2 say substitute the given points into the equation to determine which ordered pair satisfies the system of linear equations. Then graph both equations and label the point of intersection. What this is asking you to do is plug in the numbers for x and y and see if they work. Each one of those numbers there were given as an ordered pair. So for example, we have x comma y, and that's the same thing as 0 comma -2, according to what they said right here. Well, our x is 0 and our y is -2. So if I take it the first one and say y equals 3x minus 2, and I want to plug in for that, what am I plugging in for x? I'm going to plug in 0. So I now have, and then what do I need to plug in for y? -2. So I now have -2 equals 3 times 0 minus 2. So you see how I just plugged in the y and the x for what we know we have up here. Okay, let's solve it and see if it's true. 3 times 0 is 0. 0 minus 2 is -2. Does -2 equal -2? Yes. Okay, so we know that that part of the statement is true. But that's not the only thing there. We also have a separate equation, y equals x. So again, y equals x, we plug in our x and we plug in our y. Our y is -2 and our x is 0. Does -2 equal 0? And the answer is no, it does not. So we cannot use A. A is not a correct answer. Now if we continue on to B, let's try it out. Seems like the easiest one to start with might be the y equals x. In this case, does y equal x? Yes. Remember, these are x comma y, so we have 2 comma 2, and if we plug in 2 for x and 2 for y, we have y equals x, which is also 2. Does 2 equal 2? Yes. So that's a good starting spot. Now let's solve the next part. Y equals 3x minus 2. Now we need to plug in this for x and 2 for y and see what we get. The y needs to be a 2 equals, and I put it in parentheses just so you know I plugged it in, 3 times x is 2 minus 2, and we get 3 times 2 is 6. 6 minus 2 is 4. Does 2 equal 4? No, it does not. Therefore, 2 comma 2 can't be used either. Okay, and the last one, 1 comma 1. Again, let's plug them in. We have x comma y, which is 1 comma 1. So there's our x. Here's our y. Now let's plug it in. We have y equals 3x minus 2, and I'm just getting that from the problem up there. And we're going to plug in 1 for the y. So we have 1 equals, and I plugged that in, so I'll just throw it in parentheses, 3 times x. Well, x is 1 minus 2. What is 3 times 1? That's 3. Minus 2 is 1. Does 1 equal 1? And the answer is yes, it does. So there's the first part, but don't forget we have that second equation, y equals x. Well, we have y is 1, x is 1. Does 1 equal 1? The answer is yes, it does. So we see that the answer to this equation is going to be C. Now let's go ahead and graph it and see what we get. Make sure it matches up. When we're graphing a system of equations, the point where they come together, that's the answer. So y equals x. What is our y-intercept? Well, it should be right over here, +1, +2, +3. What is here? There's nothing there right now, so it's just the same thing as +0. And that's a 1x, so 1 over 1. Now let's go and graph that. We have 0, up 1 over 1, up 1 over 1, and so on. Okay, and we can draw that line. Now we have the other one, 3x minus 2. What is our y-intercept? Our y-intercept is right here. So we're going to start at -2. And then our rise over run is 3 over 1. So we go up 3, 1, 2, 3, and over 1. And we see it connects right there. 1, 2, 3, 1, 2, 3. I'm drawing the line by hand, so I want to make sure it's... And we can see that the two lines cross at 1, 1. So that's the answer. Okay. Now number 2, let's go backwards. Let's try it the other way first. Let's graph first. Our first line and second line both have y-intercepts. So this one, we're going to graph at +3, 1, 2, 3, put a point, and then the rise over run is up 2 over 1. So 1, 2 over 1. And we have our first line right there. Our next one passes at +5, so 1, 2, 3, 4, 5. And it has 1 over 1x. When there's nothing there, it's just 1 over 1. So up 1 over 1, doesn't quite pass yet. Up 1 over 1, and there we are right here. It crosses right there. And so we can draw this line and say where they cross is right here. So we can see we got to go over 1, 2, 3, 1, 2 on x. So our answer is going to be 2, comma, and up 1, 2, 3, 4, 5, 6, 7. 2, 7. We can see A is 2, 7. So that's our answer. These other ones just will not work. Okay, so that's doing it both ways. Okay, this one, we need to solve it and then check the answer. Well, let's go ahead and solve, or graph them, excuse me, and then check the answer. So let's go ahead and graph them. They both have a y-intercept of +3, 1, 2, 3. So I can tell you right now that that point is where they're going to cross because they both touch that point. This one goes up 1 over 1. And so on. And this one goes down 2 over 1. So down 2 over 1. And we have two lines. One that goes that way. And one that goes that way. And they cross right here at 0, 1, 2, 3. So we think the answer is going to be 0, 3. Now, does it work? Let's plug in a 3 and a 0. What's 0 plus 3 is 3. Okay, let's try this one. X is 0, so -2 times 0 is 0. 0 plus 3 is, and y is 3. Remember, these are just x and y. And so we plug them in to make sure they work, and they do. Number 4. We have a y-intercept here, but we don't have one here, so we're just going to add the +0. Our first one is -8. Well, it only goes down to -7, so we're just going to guesstimate right now because it goes up 3 and over 1. And that one we can do. Up 1, 2, 3, and over 1. Up 1, 2, 3, over 1. 1, 2, 3, over 1. Now remember, I keep this going so that I know all the points of that line. Okay. Now this one crosses at 0. And it goes down 1 over 1. So down 1 over 1. down 1 over 1. And if you look right there, that's where the two lines cross. So you can see why I put all the dots there. So I can just see where the dots match up. So we have our first line and our second line, and they cross right here. All right, what is the point for that? That is positive 1, 2, and down 1, 2. So let's see if that works. Okay, y equals negative x. We plug it into the original, y equals negative x. Well, remember, this is y, this is x. Does negative 2 equal negative 2? The answer is yes. Okay, just so you can see what I'm doing, I'm just saying y equals negative x, and then I'm plugging them in. We say that y is negative 2, so negative 2 equals negative, and then plugging in the x, and I'm just putting the negative there because it's sitting right here. X is 2. When we simplify that out, we get negative 2 equals negative 2, and that is correct. Okay, with the same thought, y equals 3x minus 8. We're going to plug it in. We still remember y is negative 2 and x is 2. So negative 2 equals 3 times 2 minus 8. Now let's simplify. 3 times 2 is 6. 6 minus 8 is negative 2. Does negative 2 equal negative 2? And the answer is yes, it does. So we checked our answer and we know it's right. If we flip over and look at number 5, a theater wants to take in at least $2,000 for a certain matinee. Children's tickets cost $5 each, and adult tickets cost $10 each. The theater can seat up to 350 people. Find 5 combinations of children and adult tickets that would make their goal. Okay, well, let's look through this. We need $2,000. Children's, let me do it this way. We need at least $2,000 or equal to, okay? Children's tickets cost $5 each. So 5C or C5, I should have done 5C. And adult tickets cost $10 each. So I'm going to change that to 5C. Now we need to find different combinations that will match that goal. We can have up to 350 people. Well, that means that all our children plus our adults can be up to 350. Well, look, we have 2 different equations that we can now solve. Okay, what if I try elimination? Can I do elimination? No, because if I add those together, I get 6C. If I add those together, I get 11C. That doesn't get rid of anything. So let's say, okay, let's try to find another way. We could do it by substitution. We talked about that a little bit, but let's do it this way. Let's multiply this by negative 5. Okay, so now we can multiply it by a negative 5. That gives us 5C plus 10A is less than or equal to 2,000. And the bottom we get negative 5C minus 5A is less than or equal to, and I'm going to just do this on the calculator really quick and say, all right, 350 times negative 5 is negative 1,050, or 750, excuse me. So negative 1,750. Now let's add them together. The C goes away. When we add those together, see that's gone. When we add those together, we get 5A is less than or equal to, they're both less than or equal to, we see that it gives us, let's see, do it with the calculators, 2,000 minus 1,750 gives us 250. And 5 times 8, or divided by 5, we see that adults need to be right around 50. Okay, we're just going to keep it at less than or equal to 50. Okay. Well, if we have adults as 50, well, we can plug that in, right? And I'll just get a piece of scratch paper and say, okay, C plus 50 is less than or equal to 350. So we're going to minus 50, and we get C is less than or equal to 300. So we have 300 children, 50 adults. Let's see if that gets us our goal. Remember, our goal is simply $2,000. Okay? If we have 300 children and 50 adults, what would that get us? Well, 50 times how much are adult tickets? $10. That's $500. And the children, 300 children, times their tickets are $5 each. That gets us 1,500. Add those together, that's 2,000. So yes, we can have 350. Now what if, now we need to come up with several more, right? Well, what happens if we just drop that by 1, 299, and 51? Okay, will that still work? Well, 51 times adult tickets are $10. That gets us 510. And one less child at $5 each, that will get us $14.95. Yes, that is still over the $2,000 goal. So you see, you start and find what would equal, and then you can adjust it little by little until you get it right. So I would say 299.51, then 298.52, 298 or 7.53. And you see how we're just changing them little by little, going from one child and making it one adult. Therefore, we ensure that we always stay over 2,000. Okay, so that's how you do number 5. And that can be more complicated. So, do your best on 5, and if it doesn't work out, then you can, just turn in what you have. I'm not going to be too concerned about number 5. We're still working on that. Okay. Number 6, graph below and determine if the point 3, 5 is a solution. That means let's see, 3, 5 right here. 1, 2, 3, 1, 2, 3, 4, 5. Oops, wrong. Let me change that so that it's a little more correct and not just a giant blob. Okay, so let's try it again. 1, 2, 3, 1, 2, 3, 4, 5. I want to know if that's part of the line. Will the line touch that point? Well, what's our y-intercept? Our y-intercept is -1. And our slope is 2 over 1. So up 2 over 1. Up 2 over 1. Up 2 over 1. And look, we land right on that point. So yes, when we draw that line, we see that it is part of the solution. Because remember, that line is all solutions. Okay, so once again, here we want to find out if 1, 2, 3, 1, 2, 3, 4, 5. We want to find out if that's part of the solution or part of the line. We have +2 as our y-intercept. So right here. And then up 1 over 3. Up 1 over 3. Up 1 over 3. Up 1 over 3. And notice we're just kind of going right past it. 1, 1, 2, 3 right there. So that one goes there. But anyway, we see it does not cross that line or that point. So this one, 6 is yes, it is part of the answer. 7 is no, it is not part of the answer. Number 8 is 3. 1, 2, 3. 1, 2, 3, 4, 5. Is that part of the answer? Let's see. We have a y-intercept of plus 5. So 1, 2, 3, 4, 5. And then down 3 over 1. So down 1, 2, 3 over 1. 1, 2, 3 over 1. And we're not going to pass that line at that point. We can see the lines going like this. And that's not going to cross this point. So the answer is no. Okay, one more. 1, 2, 3. 1, 2, 3, 4, 5. We want to find out if that's part of the solution. Our y-intercept is positive 4. So 1, 2, 3, 4. And then we're going down 3 and positive 5. So 1, 2, 3. 1, 2, 3, 4, 5. And we can see that that line, as we draw it, is not going to touch 3.5. So the answer to that one is no. Okay, so that's how you do system 2.1. Don't worry so much about number 5. Don't let 5 get you fooled, but that's how you do it.